Hi friends, this is based on the plus 2 level chemistry chapter 2 solutions. We know different type of solutions are present such as homogeneous and heterogeneous one. Homogeneous solution means it's a mixture having one or more components. We all know a solution is formed by the combination of solvent and solute molecules. The concentration of solute molecules will be less compared to the solvent molecules, hence constitute to form solution. For an example, if we are taking a sugar solution, here the water is act as the solvent and sugar will act as the solute, and both constitute to form solution, and it is an example for a homogeneous solution. We can move and understand what are the different type of solutions. First one is the gaseous solution. Here the solvent will be gas always and the solute will vary such as gas, liquid and solid. We can look into few examples. That is gas in gas. Example, the mixture of oxygen and nitrogen gas. Another one is the liquid in gas. That is chloroform in nitrogen gas. Another one is the solid in gas. That is camphor in nitrogen gas. These all constitute to form the gaseous solution. And next coming under the liquid solutions. Here the solvent will always liquid. And coming into the solute, we can see gas in liquid. For that, we can see oxygen gas in water. Liquid in liquid, that's ethanol in water. Solid in liquid, glucose in water. And next coming under the solid solutions. Here the solvent will always solid and the solute will vary. Gas in solid. Example is hydrogen gas in palladium. Palladium is a transition metal. Another one is the liquid in solid. Here the mercury, Hg4 mercury amalgam in solid solution. Here it is sodium salt. And another one is solid in solid. Here it is copper in gold. These three constitute to form solid solutions. Next we can understand how the concentration of solution can be expressed. The first one is the mass percentage. Based on the mass of component in solution to the total mass of solution into 100. Here we are expressing the mass of component in percentage. So we are multiplying the mass of component solution to total mass into 100. And another term is the volume percentage. As same as like the mass percentage. Volume of component to the total volume of solution into 100. And another one is the mass by volume percentage. Here we take the combination of mass percentage and volume percentage. That is mass by volume. And another term is parts per million, which we in daily life we can see it as ppm. Number of parts of component to the total number of parts of all component of solution into 10 raised to 6. Thus, these are few parameters for expressing the concentration of solutions. Next, we can see next term is the mole fraction. Here we are representing the number of moles of component to the total number of moles of all components. The mole fraction can be expressed in small letter x. That is, XA is equal to Na by Na plus Nb. Na signifies the number of moles of solvent molecules and Nb signifies number of moles of solute molecules. Xa is the mole fraction of the solvent molecules. And we all know the mole fraction of different solutions such as x1 plus x2 plus x3 plus etc. to xn is equal to 1. And it is always helpful for the calculations. And the next term is the molarity, which is represented by the capital letter M. It can be expressed as moles of solute to the volume of solution in liter. The unit is mole liter raised to -1 or mole liter inverse. And another term is molality. It is represented by the small letter m, which is expressed as moles of solute to the mass of solvent in kilogram. The unit is mole kilogram inverse. By looking into this molarity and molality, we can find a difference in both. Molarity is represented as the volume of solution in liter, while molality is represented as mass of solvent in kilogram. Thus, the molarity is a temperature-dependent quantity. As the temperature and volume is related, as temperature changes, volume of solution also changes. Thus, the molarity will change. Thus, the temperature-dependent parameter is molarity. But in case of molality, we can't see any terms such as volume. Thus, the molality is a temperature-independent parameter. These are few parameters which is used to express the concentration of solutions. Thank you for watching this video. Have a nice day.